Hi, my name is Damien McNamara and I'm a Specialist Solution Architect with AWS. I'm going to demonstrate how to perform quality analysis for on-demand content using AWS Elemental MediaConvert for frame-by-frame video output quality measurement. MediaConvert can generate reports with industry-standard quality metrics. These can be used, for example, to evaluate encoding decisions with objective quality measurements, compare different encoding settings with different outputs, identifying specific frames or scenes that have low video quality, validating that your encoding settings meet your business quality thresholds. Now let's jump into the browser for the web demo. On the right-hand side, we have a HLS video player taking the output from MediaConvert with an example adaptive bitrate ladder, which has various resolutions and bitrates. On the left-hand side, the graph shows the metric score per output, and this updates as the video player progresses and it's synchronized. This demo uses the VMAF metric, a perceptual video quality assessment algorithm developed by Netflix and open sourced. VMAF provides a score of 0 to 100 that correlates with human visual perception. Other industry metrics supported include PSNR, SSIM, and the QVBR quality level. So this example clip was encoded with MediaConvert using the automated ABR feature. It has 5 outputs ranging from 1080p, around 4 megabits. And as we can see, the average VMAF score is around 95 or greater, which correlates with a score of excellent. Now, what excellent means is that the content that's output from MediaConvert is virtually indistinguishable from the source content. And as we see the video playing, we can see all the various outputs are basically correlated with those scores. So it's fair to say that this content is high quality and you can validate that with this data. For further analysis, you can dive into the data page, which has a tabular result of all of the outputs. Okay, so what if we want to now optimize further and reduce the bit rates? So what is the data required to store and deliver this video over your content delivery network? So I'm going to switch from the current automated ABR example to a manual ABR ladder that I've created earlier. Now, as we can see, this stream has 2 outputs. They're both 1080p and they both have an average score of 95 VMAF points. The first output is using the AVC H.264 codec. It's around 2.63 megabit on average. The second output is using different compression codec, HEVC or H.265, and it's around 25% less data at 1.96 megabit. So as we can see, this is a use of the data where holding the VMAF score constant reflects the relative comparison of the bitrate for this particular example. Of course, real-world examples and results are going to vary considerably depending on the content type, but you can see now by having a metric, you can experiment with various encoding parameters to optimize. So an example experiment could be to try various bit rates until the VMAF score reduces by 3 points. This is typically known as the just noticeable difference point, or JND. Okay, let's take a closer look into scenes where the metrics may be lower than our target VMAF score might ideally be. So I know that at 48 seconds, there's a drop. You can see it here. There's a dip where the VMAF score for AVC is sitting around 75. If you look at the video player on the right-hand side, there is high motion here. There's a lot of background detail of the crowd. And in this case, the source content has a motion blur. So I'm expecting that to be the case. But this is a good example of a scenario where by identifying the scene of a dip in the VMAF score or quality score, you can zoom in and make some inference around what encoding parameters might be necessary to improve this, such as perhaps increasing the peak bitrate for your MediaConvert job. Of course, decisions on what quality to target really depend on your business requirements, the types of content, and the display devices or target screens your services is available on. And finally, of course, for any testing, it's critical to do some subjective testing of your eyes. So in this example, you can go full screen in the video player and choose the output that you wish to evaluate. Typically, this would be done at 3 times the picture height from the display. Okay, hopefully this is useful. Thanks for watching. And to get started, enable per frame metrics on your MediaConvert jobs